What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to look at the start of linear relationships, specifically the table of values, which communicates a whole heap of information to us really simply. So linear relationships is just a combination between algebra and graphing. It's really important because it helps us model things in the future. If we've got a limited data set that's acting in a really predictable way, we might be able to extend out our knowledge to tell us something really interesting. So the major part about linear relationships that we need to get down is that you're always going to have two variables, and these two things are related in some way. So that means that they might grow together or they might shrink together. One might grow and the other one might become smaller, but either way, these two things are tied exactly to one another. So we're going to look at an example here. So for this example, what we want to do is make squares out of matchsticks. So we're going to use 4 matchsticks to make that first square. The square has 4 sides, so that makes sense. But as we want to add another square into this pattern, instead of using a whole nother 4 matchsticks, we can use one of the original side lengths, so we only need to use 3 matchsticks instead. And this pattern is going to hold up. Every single time we want to add another square, instead of adding 4, we can add 3 extra matchsticks into our pattern. So this means we're going up in a very predictable way. Every time one square is added, we need to go and get 3 extra matchsticks once we've accounted for that first square with the 4. So if I was going to put this into a table of values, I've got my squares up the top, and they're going up by 1 every time, just like we saw in that example. And we know that the matches started with 4. We need 4 to hit that first square up, otherwise we've got like a triangle or something. And then every time after that, we just need 3 additional matchsticks. So as squares goes up by 1, the matchsticks we need goes up by 3 after starting with 4. So if we were going to put into words what we just saw, all that's happening is that for every extra square I want to build, I need an extra 3 matches. But that first square that I started with 4 matchsticks. So the pattern is after starting with 4, I need 3 every single time. So you can see how this could be really helpful. If I asked you to make 50 squares straight away, instead of making them out and guessing how many matchsticks you would need, you could just work this out before you got started. So the formula for that would be, I've got my first square, which is 4 matches, plus I need 49 more squares, and for each of those I need 3 matchsticks, so I could do 49 multiplied by 3. If you type this into your calculator, it's going to give you 151, and that's how many matchsticks we would need to make these 50 squares. So that's just an example of modeling. We've got information, and then we can extend it out in order to save us heaps of guess and check. So the only skill that we need to know for linear relationships is if you can see the pattern between variables and explain what's happening in words, I guarantee you're going to be fine. So let's have a look at this example. Instead of using squares and matches this time, I'm going to use letters X and Y, and they become really important when we start graphing. So as we can see in this example, X is going up by 1. That's totally fine, but we're really interested in filling out these blank Y terms. So because we know the pattern is repeating itself over and over again, we can work out what these boxes are. So it's going up by 5 every single time that X goes up by 1. So to change that 20 into the next box, I just have to add 5. So that becomes 25, the next one's 30, 35, and then 40. And that makes a whole lot of sense. So if we were to put this pattern into words, and that's the important part, what we would say is that as X goes up by 1, every time X goes up by 1, Y goes up by 5. And that's all we've got to do. This can also go the other way. So in this example here, X is still going up by 1 every single time, but Y has started at 12, and this time instead of increasing, it's decreasing. So Y goes from 12 to 10 to 8, so it's decreasing by 2 every time, so we can fill in the rest of these numbers. So from 8, it's going to go down to 6, 4, 2, 0, and it is allowed to go into negatives, so that's going to become -2. So if we had to say the pattern for this one, we would definitely need to say that every time x goes up 1, again, so as x goes up by 1, y goes down by 2. It's really important though to tell us what number you start with. Okay, if we just said as x went up by 1, y went down by 2, you wouldn't know which number to start with. So we would just have to say in this example, we were starting at 12. So the major skill that we need to know, as long as we convert what is happening within these numbers, we're going to be totally fine. We've got one more example just to see what happens if x is slightly different to just going up by 1. So in this one here, we can see that x is going up by 5 each time. So the jump is not the 1 that we've been used to, but it's still happening in the exact same leap each single time. And so as x goes up by 5, my y term has then gone down by 10. So I can fill this pattern out again. So from 40 to 30, I can go down to 20, down to 10, past 0, into the negative 10s. So if we have a go at explaining what this pattern is, we could say that as x goes up by 5, y goes down by 10, starting with y is equal to 40. So we can write that down. X goes up by 5, y goes down by 10, starting at 40, and that is our final answer. If you can do this one skill, read off the table of values, I guarantee you're going to find linear relationships pretty easy. It's just this pattern recognition that is foundational to all the other things that we're going to do. Thanks so much, guys, and I'll see you later.